Okay, this is assignment 24 PreCalc, chapter 2, that's 6, example 2. Find the vertical and horizontal asymptotes. Find all vertical and horizontal asymptotes of the graph of each rational function. So these are functions, okay? The rule is a function. So this is kind of answer key. They show you how to do it, but I want to go through with you step by step. The first you see the rules of horizontal and vertical asymptotes. This is how you find horizontal asymptotes. Okay. Um, First, this is first thing you have to compare leading exponents of numerator and denominator. Numerator exponents, leading means biggest exponents is 2, x to the second power, so it's 2. Denominator is also 2. So when the numerator and denominator are same, state the leading exponents of numerator n, and state the leading exponents of the denominator as d. So in that case, if n equals d, if it's leading exponents as they are same of denominator and numerator, you get the ratio of the coefficient. So this is 2, this is 1. So answer is 2 over 1, right? So that's the horizontal. So it's parallel to x-axis. So it's y equal 2, means I use a dotted line here, and I use color red. I don't know which red is. Okay, oh, meant to be. This red is line. What did I do? Okay, so let's go this one. So I'm sorry, y equal 2. So line here. So this is horizontal asymptote. So I should go this way. Now I will change the color to red. Oh, let me see again. Red color. Right here. Okay. That's the horizontal asymptote. Now, this process you have to do before factor anything on the numerator or denominator and compare it. Okay. Now, as you see, is a difference of square right here on the denominator. So you can rewrite this question 2x to the second power. Let's see, go to equation 2. 2x to the second power. The denominator is x plus 1 and x minus 1. Sorry. Okay? So, well, you see this right here. This function f of x here, you can rewrite this way. Now, in math, you cannot have 0 on denominator. But there is a number, it's approaching to close to this is 1. I'm sorry, negative 1 here. If you plug in 1, it's going to be denominator is 0. And this is, if you plug in negative 1, it's going to be 0. But there is a number approaching to this one, or from negative side and positive side, right? So that it becomes vertical asymptotes. So I will choose x equal negative 1, which is this way. That's called vertical asymptotes. For both direction, and I use color green. And you see this x equal positive. Okay, here is a little bit tricky part. So this is you find vertical asymptotes. This is a little bit sketch I wrote down to find. Later on you need this exercise. So from negative infinity, x equal negative infinity to um, x equal negative 1, which is here. I'm sorry. This should be this way, and this should be this way. And also there is a property from x equal negative 1 to 1. When you enter this, you could kind of see is positive or negative, or mostly negative. For example, if you plug in x equals 0, you find out what this one is. So let's see, if it's x equals 0, it's going to be negative or negative 1 on the denominator. However, it's going to be 0 on the numerator. So it's going to be 0. So it's going to be 0, 0. It's going to be exist here. This must be, I should have written this one going 0, 0, origin. Okay, I hope you understand. So this is supposed to be going origin here. That's the x-intercept, right? Because if you plug in 0, it's going to be negative 1 stays here. So it's math, it's okay, but 0 over negative 1 is still 0. So it's 0, 0 supposed to go here, right? But it's from here to here, it's approaching here, so it's going to be graphed like this, okay? And if you asymptotes, it's never touching here. So this line will never touch. This line will never touch, and which is getting close to x equal 1 is getting close to positive infinity. Okay, this one goes to positive infinity and approaching to x equal, I'm sorry, y equal 2. I hope you see it's a little bit easy for you to understand later on more exercise, okay? So at this point, I would like you to answer y equal 2 for horizontal asymptotes and x equal negative 1 and positive 1, okay? That's the vertical asymptotes. Let's go to next question. Next question is f of x equal x squared plus x minus 2, that's the numerator, over x squared minus x minus 6, that's the denominator. So as same as the previous question, the horizontal asymptote, so state what the leading exponent is. So leading exponents on this is second power. Denominator is also second power. So you compare the leading coefficients. So 1 and 1, the y equal 1. That's the horizontal asymptote. So did I get the graph? Okay. So y equal 1. Let's see. Y equal 1. So it's, if you see this, y equal 1 is going to be here. Okay. And I will change this one to red. Or horizontal asymptotes. Now, you can both numerator and denominator can factor, right? So x plus 2 times x minus 1 is going to be here. X plus 2 minus x minus 6. So you can do x minus 3 times x plus 2 over here. Now what do you see? Is that because there's a multiplication, you can cancel one pair, numerator and denominator. So I'll use a crayon tool to cancel this. X plus 2 and x plus 2. Now, can we plug in x equal negative 2? In math, it still becomes 0. So you cannot have x equal negative 2. But this won't appear as vertical asymptote. However, this will appear as vertical asymptote. So I use this tool, line tool, x equal x equals 3 is going to be around here. Okay. So that's all you have to do for this. Let's assume what is y-intercept is. Y-intercept is when x is equals 0. So if you plug in 0, it's going to be negative 1 over negative 3, which is 1 over 3. So it's going to be a little bit above 1. So this, since this is y equal 1, I'm a little bit above 0. So it must be, I can't zoom here, but it's going to be around going here. Going here. Okay, 1/3 of this. It's not origin, 1/3. And if it's approaching here, it must be going through here, and it's not touching, so it must be going through this way, like this. So it must be symmetry over this point, asymptotes meet. So it goes to go this way. Next week's test, you don't have to graph this, but I would like you to come up horizontal asymptotes, which is x equals 3, or what will happen to x equal negative 2, right? So the one thing you have to do, x equal negative 2, it's going to be little space here, because it's supposed to be, it's not exist. So I will put the open dots here. At this moment, you don't have to graph this, but I want you to know. So I have to use a eraser to erase here and create the line to go skip this number. Okay, that's the horizontal asymptotes. So we did 2 examples of the example 2. I was going to do the example 3, but just do the example 2, and we will come back for examples during the classroom time. Okay, I will play one tune. So that is for today for asynchronous work. Hope you're having a good weekend. Let's see, I will play a bossa nova to the Brazilian tune. So.